be careful about talk. Go ahead, Kathy.
Hello, and yes, welcome to September. I've been waiting all summer, and we also have a wonderful month because we have some of our favorite planets back, and I will show you how to find them. First, we start with a little space news, anything that is really been important that happened recently, as opposed to plotting down here on Earth, working out computer problems the way we did tonight, MacGyvering our PowerPoint and watching old movies, new movies, whatever. A little jocularity to start us off. Okay, I'll be mostly serious. As many of you know, India has risen to the ranks of very prominent countries that are doing space missions, and every country has wanted to land on the south pole of the moon, including us. So, and several have tried and failed. So actually, they were just a week or two ago, they landed, and this is great because it's the image. It's the first showing the lander through the rover's eyes, which is wonderful. And they landed Chandrayaan, I hope I'm saying that right, 3 mission landed Wednesday, August 23. So we welcome our fellow scientist friends. They're also going to be studying the sun, so that'll be tomorrow. They have a busy week, and they'll be they're their first space-based Indian mission to study the sun. Also, sad news, this week we lost astronaut Jim Lovell's wife, Marilyn Lovell. Looks like such a lovely lady, and there she is in her younger days, on the 27th. And on one of Lovell, obviously, besides being commander of Apollo 15, he was on Apollo 8, and he actually, in her honor, named one of the mountains on the moon, particularly distinctive triangular shape there, Mount Marilyn. So for many other reasons, we will not forget her. 93, I'm glad. Sounds like she had a nice long life. Coming up, the autumnal equinox. This is going to be September 23rd. Some of us are, very sad that the nights are slowly getting darker sooner. Astronomers, at least I love it because the cooler weather's coming and there's more to see earlier and earlier. So I'm very happy about that. When you hear things like equinox and solstice, one of the ways I keep them straight, equinox has that equal sense of a word root, and that is spring and fall, mild temperatures, equal day and night. And so that's how I can always remember. And here's a little diagram, showing the June and December solstices and the equinoxes in March and in September. We are neither tilted away nor towards the sun. So interesting note, I know we were all excited about the recent supermoon, and we've had several this year. And this was the one of all the supermoons that are generally at a point in the orbit around the moon, a little closer at one point than at another time of the year. So actually, as it turns out, this one that was August 31st, that was the closest of all the perigees, we call it, the shorter distance, as it moves not in a perfect circle, but in an oval, and sometimes you're closer to what you were orbiting at some points than others. So actually, it was the supermoon of the year. As you can see here, this doesn't exactly show the unequal oval shape, but interestingly enough, It's the tilt towards or away from the sun that makes it hot or cold. And interesting, between December and actually July, the December solstice, the Earth is actually closer to the sun than it is in July, which is very strange. It's a cool factoid, and it does show you that indeed it's not the small change in distances, but it is how you're tilting. This is kind of a nice little gift here. There's the solstices at the top, the summer and the winter down there, and then on the equator you got the spring equinox and then the fall equinox. So that gives you a little idea of the way the sun's most direct rays hits the earth in each season. I'm really hoping that in terms of how we move around the sun, that we get into fall sooner rather than later. By the way, a personal note, I gave a telescope. I have two telescopes of the same type. I gave it to my youngest daughter. She and her boyfriend went August 31st. They started, I'm sorry, August 30th. They started with binoculars I gave them because I tell people, if you have binoculars at home, that is a great first piece of equipment. Obviously cheaper than, scads of money that you can spend on a decent telescope. But really, you'd have to spend maybe 150, 200. When you see, the magnification is the biggest add on the package, that's usually bad because you can magnify a very fuzzy, unclear object, okay? So what you really want is to check the dimensions of either the mirrors or the lenses that are involved in a telescope. And we have all information on our web on how to choose a scope. Also, we love to talk about the hobby, so ask any of us. But what I say is get a decent 7x35, 8x50. I got my first on eBay for $35 about 20 years ago, but you can still get decent binoculars, and they're baby telescopes. So you look at the sky with your naked eye, and then you use binoculars. You probably have a decent pair at home, and you can see many, many more stars. The moon is gorgeous. You can sometimes, if you hold it really steady, make out Jupiter and the 4 moons going around the planet. That's a beautiful thing. And like I said, give it a try. But they were looking at the moon, and then I said, I had gone out and I realized Saturn was just off to the right. And I said, just move a little bit. And they hadn't really tried to put anything smaller than the moon in the eyepieces, and they got Saturn. So that's the first time. It's a tiny little thing, even in our scopes, but it's definitely got the shape. And that is really thrilling to people. I remember the first time I actually got the right aim and saw it. So anyway, that was Bay Ridge, Brooklyn, and I'll never forget. Okay. Coming up is actually the last of the year's 4 supermoons. You've got the harvest moon. This is a nice little bit of information and a graphic from Farmer's Almanac. It is the name assigned to the full moon that falls closest to the autumnal equinox. And it varies depending. Sometimes if it's a little closer to October, the moon that is closest to the date of the equinox gets the full harvest moon moniker. The cool thing is, and I wanted to just get one extra slide about this. Apparently, one of the ideas behind calling it the harvest moon is that the moon rises only about 30 minutes later on successive evenings. So you sort of get maybe 3 days of the super moon. Not technically, but you know, for all intents and purposes. Usually it's 50 minutes or so for successive evening. So farmers who work late try to harvest their crops. So they found that very helpful. And something that kind of clears it up is because of the way the moon and the matter to each other in September is different from other types of the year. Just because the horizon is a little shallower. So as you can see, let's say sometime in around the harvest moon time, we've got 8 p.m. Then the next day it's rising at 7:30 p.m. The next day 7 p.m. and it's very shallow, so it's closer to the Earth and giving you a lot more light than, let's say, a March full moon. You've got quite a difference in the angle. So I thought that was very cool, and this graphic was very helpful in imparting that information. We have got planets. At some point during the day, we have all of these. First, we start first thing in the morning. We've got morning planets. And right now, the second half of 2023, Venus is in the mornings, about an hour before sunrise. And if anybody, you've all probably seen Venus in the night or the evening sky or the morning sky, but it is extremely bright. It's the brightest thing in the sky except for the moon and of course the sun at night, but sun in the daytime. But it's one of those, what is that up there? Jupiter's another one that in its, its best months, it will be so bright. It will be very, kind of very surprising. And it's like the moon in that it's an inner planet. We really only see it in stages, like the moon, the full moon, half moon, etc. And we only see, crescents of some with. It is going to be brightest for the year, September 19th. So mark that in your calendars. Also, while you're up, you can see in the graph on the left, Procyon, that is a star that is connected to what we call the winter triangle. It involves Orion, Betelgeuse in there. It involves that whole area of the sky. So if you're up, get up a little earlier, you can, if you look to the right, see a little more of Orion, which is a lot of people's favorite constellation. So should you be getting up early, and a lot of us like to do that, it's really worth it, because you can see so many. Somebody leaned wrong. So many planets, depending on when you go to bed. Saturn is one of our favorites, and it is back. It is rising above the trees. We should be able to get a good view tonight, so I'm going to try to not take too long in telling you what you could see. If the weather was good, we may actually get decent weather. So this is just one of my favorite gifts, because it shows the rings of Saturn having ice and dust, some just the size of a piece of dust, and some rocks as big as a school bus. And the reason you can see Saturn's rings and you can't see the rings of the other outer planets, Neptune has a ring, Jupiter has a ring, Uranus has a ring. As a matter of fact, Uranus got knocked on its side, so it's actually on its side. I'll show you a graphic of it. But they're only dust. So the fact that Saturn has that ice that gets reflected, that's why it's some of our favorite planets. It's in Aquarius. Here is a picture, and I believe our friend Cliff is on tonight on Zoom. He took this last week. This is a view of Saturn. We have been dealing with atmospheric difficulties and humidities and This is one of the rare Friday nights that it's non-cloudy. But you can see the Cassini division here. And one of the amazing things about Saturn, and we'll get into that next month when we talk more about it, is the globe itself is so fascinating. Really fascinating. Down here, you can't see it clearly here, but there is a hexagon that is shaped as if somebody took a ruler and actually drew it on the planet. And it's basically a storm of great power. But see, it rises at sunset, and it's by about 10 p.m. It's a good 30 degrees. Remember, from the horizon to the zenith is 90 degrees. Then you have 180, and then 360 is your full circle. So that helps orient you. So if you're halfway up in the sky, or not quite, that's about 45 degrees. So it's clearing the trees, and we shall look to have a good viewing. Like a good astronomer, Cliff, he has an observatory in Grineville himself, and he works very well. He's one of our best astrophotographers. You notice he has S up, meaning that since a telescope inverts an image, you're looking at something upside down, okay? Sometimes it doesn't matter. But for Saturn, now Saturn goes from no tilt at all of the rings to 26 degrees. You can see this is how it looked in Cliff's telescope. This is actually, if you were standing outside of Saturn, this is how you would see it. The rings are dipping down. And each year, the tilt changes. So last year, this was the tilt. That was 14 degrees. And then the year before that, it was 18 degrees. So you can see it slowly moving up, and you can see more of the bottom of the planet, okay? And a lot of us remember not too long ago, we could hardly see anything but the actual globe of the planet. No rings at all. This gives you an idea here. We are here, okay? And then next year, it's going to be very, very, very shallow. And the year after that, you really aren't going to be able to, enjoy the rings, but you can enjoy the actual planet because like Jupiter, it has bands, it has colors, it has features that are absolutely fabulous. And we had a recent Cassini visit spacecraft that took incredible pictures. And we will present that more next month. Want to kind of get you out of here. But anyway, this year, I think this is the time to really enjoy Saturn, okay? It's going to have to last a few years. There is a picture of it in the sky. It's kind of low on the horizon. You can see that because of the way our solar system is built, the plane of the path of the planets and the sun, and for the most part the moon, they're all on one plane. And in the sky, during the day or at night, which is when we can appreciate them, they're always traveling with the Zodiac Constellations. That's something very helpful to know. And the Zodiac, the arc, obviously it became very prominent in astrology. You have to keep reminding people, we're not astrologists, we're astronomers. That's very nice, but I can't tell you your future. The sun rises in the east and sets in the west, okay. And then the constellations, they're there during the day because you've got those great apps on your phone. You can even find out where, Venus is during the day. But they rise, and then with each season, another set of constellations comes up, goes overhead, and then towards the end of the night, they're done, and you can look at the next round. It usually is not directly overhead, it's slightly off the top, slightly south, okay? The good thing is, see, this is where Saturn is, And in the summer, it turns out that the ecliptic, that's the name of the arc, the ecliptic is very low. It's kind of hard to see the summer zodiac constellations. And so many of them are so beautiful, like Sagittarius and Scorpius. It's a shame, but you know, we always look for a good horizon. But you're never going to see a planet over there. Like we're standing here, you know, that's kind of south, east, north, west. You're never going to see anything over there, let's say the Big Dipper is, which is a northern constellation. That helps you, okay? And that's why, of course, the Zodiac constellations got so famous. So that'll show you, I will show you a full map of all the constellations of the late summer, early fall, later. Neptune actually is up there. It's at the border of Pisces and Aquarius. Again, you'd need a telescope for that. But for those of you who love photographing the planet, it's going to be in opposition halfway through September. And that just means it's directly opposite us. The sun is here, we're here. The planet at opposition is there, straight line. We can see it because our nighttime, we can see the sun shining on this side of the planet. And it's the best time to see a planet. Jupiter, that's rising. If you stay up late enough tonight, I mean, it's just rising at 11, but really in a month or two, that is going to be another planet to look for, Saturn and Jupiter. And they're kind of two of the most thrilling things, I think, to see. And it'll be about 40 degrees at 11 p.m. at the end of the month. So if you hang around here towards the end of the month, you could get a very good view of Jupiter, our largest planet. Here it is. It's just below Aries. And actually, that starburst look. This will be actually, you could follow, you could follow it anyway because it's so bright. But the beginning of September, the moon will kind of be in this kind of viewing, just the way this drawing shows. And it will be just Aries on top is not really a very bright constellation. Taurus down below, Aldebaran right at the bottom. That's the only part of Taurus you can see. But with binoculars, by the way, Taurus is one of the most beautiful constellations because it shows different sizes. And there's colors. You actually can see colors. I'll tell you a little more in a moment. But the fact that you're looking for Jupiter, you really don't need color. It's that big, what's up there, planet. Jupiter in binoculars, by the way. This is a good instance of what you can see. Jupiter has a ton of moons. I tried to get the, it's 60. I think it's even higher than that every day. They're getting more numbers, and I want to put them in for next month when I get a good total. But the four largest ones, Galilean moons, they're a lot of fun to see because they switch position every 2 hours. So you can really see how everything's moving. The universe is constantly moving. This gives you a good idea of what you can see in an aeroscope. There's a good kind of view of the bands of Jupiter there. And it does have a golden color, okay? Some things like Mars looks to the naked eye reddish, flesh colored, red star. But in binoculars, it loses its, in the telescope, it loses its color. Jupiter maintains its color. It's really a beautiful sight. Whoops, sorry. And there's the Galilean moons. They are fascinating by themselves if you ever want to Google something fun. And they're named Galilean moons because Galileo discovered them, and the fact that he was discovering something orbiting a planet changed our view of who's orbiting who and who's in the center of the solar system, et cetera, et cetera. So, but they're just gorgeous all by themselves. Constellations. This is your early fall chart. And when you look, we actually have charts for you to take home. Don't be frightened by them. I mean, obviously, when you look up in the sky, you know, the lines and the words aren't there, but you can see there are some what I call big dot constellations, and we can see them in New Jersey. I learned pretty well my way around the sky, even though we don't have these dark skies. The first time I went to a really dark sky, I think it was northern Vermont, it was astonishing and I was gobsmacked, but could I learn patterns there? I don't know. I figured out, let me be happy with New Jersey for a lot of reasons. And sometimes it's better just finding your way around this way. And you can see that some of the stars have different colors. There's some very bright ones, like this star in Cygnus. These are going. This is part of what was called the summer triangle. Cygnus is the swan. We're just going to mention it a few times tonight. Aquila, that's Altair, a major star, and up here in the constellation Lyra is Vega. And for those of you who love Carl Sagan and his Contact in the movie, that's where the radio signals were coming from to Jodie Foster. That was Vega, and it's one of the brightest stars. So that's gorgeous. When you go out, when it first gets dark, and that's going to change over, you know, the weeks, but when you go out, those guys are pretty much overhead. So we're not done with them. But it's a great way to find your way around the sky, you know, so you know that the new constellations are coming from the east. It's very hard to look at a flat chart because basically we're talking about a dome situation. But you read the instructions, it'll tell you where to stand, you face south, put it over your head, and you can pretty much find out what's, you know, north, south, east, and west. So those are the things that you are going to see. Let me try to, we are going to go over for the first time, two constellations that will probably be overhead as the month of September go on. Andromeda, which is kind of attached to Pegasus. Okay. What I wanted to show you here was where the planets were, because here it'll take a little later. You know, you'd have to stick around midnight or later to see these folks, but this is where all our planets are, so that you could just check it out. This is Aquarius. I think I showed you before. Saturn, very low in the sky. Again, its neighbor, Capricorn, that is another zodiac constellation. And here you've got the teapot of Sagittarius. Let's go this way. This is Pisces, and this is where Neptune is. And then below Aries, this is where Jupiter is. And then Uranus here, it's under Aries right here. And you'll notice Taurus is up here. See this line? They're all the ecliptic arc. Okay, and that is where all the planets are going to be. All right. And in the wintertime, the ecliptic gets a little higher, so you're not craning your neck. One thing I wanted to show you was, since we can't forget about Lyra, Cygnus, and Aquila, there's something here that doesn't appear in a lot of maps, and a lot of us are not familiar with it, but we have our members, two of them, took beautiful photographs of deep sky objects. One's a nebula, and let me just see here. The constellation is Valpecula. Am I saying it right? But I don't think I've ever said it before.
Valpecula.
Sorry?
Valpecula.
Oh, the accent is on the other syllable? Okay. Anyway, it's known as the fox, and this is the first time I saw. You've got the beautiful mythological. This is the swan. This is Cygnus up here. See the cross, and then over here is the harp. Sometimes it's an eagle, but you can see kind of the harp parallelogram shape of the constellation Lyra, and there is Vega. But trying to catch, apparently, this is an old late 1800 drawing, but apparently the fox has a goose in its mouth. So anyway, but it's not, again, it is not a big dot constellation. You will find things that are around it, but with the telescopes, our trusty people, here you go. Here is the sky map, the constellation graphic of that name I said before. I don't have it in front of me. Anyway, so actually, what was prominent is a few weeks ago, I saw it in Facebook, some of my friends, and I also got emails from our science committee, which really is a marvelous committee. They actually do a lot of research and actually create some science. So anyone's welcome to join. There is M27 called the Dumbbell Nebula. A lot of you have heard of it. There are actually two, sometimes you have M15, M42. That's Charles Messier, a Frenchman who really cataloged a lot of the deep space objects. There's another later cataloging that's new general catalog. So you will see, I don't know if you can see it here. Yeah, it's supposed to be NCG, good old 6823 and 6820, but that's got a better name. And then here, see, I guess it's Colander 399. Wait till you find out what these numbers translate into. First, our member Omar, it's Valpecula. Did I do it right? Never mind. It's not only a reflection nebula, but there's an open cluster of stars. And this is particularly gorgeous because it sort of has that solar creation look that you find other places. One of the most famous ones is in the Orion Nebula, but that was very interesting to the whole network of astrophotographers here. They were all patting Omar on the back. And for those of you who are really into photography, they usually give some information about the picture. And this was obviously done 2 weeks ago. And then our member Wayne Zuhl, this is the Dumbbell Nebula. That has a Messier number 27 and NCG, which is New General Catalog. And this is amazing. Nebulas are really what's left, or really in the process of a dying star, and we will, our sun will one day become a nebula when it starts to warm up rather than being red hot and swells, and gives a reddish tinge, and then there is a shell that expands, and this is just gorgeous to see. Again, if you'd like to Google lifetime of a star with a nice chart, do that, because we learn more about our sun the more we learn about this. One of the things, this isn't anybody's special photograph, but one of my favorite binocular views is something called the coat hanger, also Pegasus Cluster, or CR 399. And it's gorgeous, and you can see there's different colors in the stars. Actually, it goes from blue-ish, blue-white, then it goes white, off-white, yellow, golden, red, flesh color, orange. And actually, at the orange end, the stars are cooler. They're not the red hot stars. The really hot stars at the beginning of whatever lifespan, some of them, live quickly, die quickly, and they're gone. But the beginning, you're blue white. So that's something that's fascinating, and you can get a sense of color, and that's where everything is. There you go. You would need a telescope for that. You would need a telescope for that. But here, if you look, you see the swan. You go down towards the end, and the last star, which is really a double star, Alberia, really beautiful. If you go down a little bit and slightly to your left with your binoculars, you will catch it if you go slowly enough. That's something any of us can look at and enjoy. I don't take my telescope out as much as I take my binoculars. Okay, coming back here, we are doing these two constellations. The one I want to show you here is Pegasus. Okay, Pegasus is a beautiful white horse. It was born from when Perseus, a big hero, actually slew Medusa, the lady with the snake here. And this is the PG version. And when she died, out sprung this gorgeous white horse, and that is Pegasus. So we just love this, and we'll do a little bit. Well, bless you.
Thank you.
Well,
Mute you.
yes, everyone remember to mute yourself. Okay. The name Pegasus is derived from the Greek, which means springs or waters. And I think that with this effusion of a beautiful unicorn-like white steed hopping from the waters of Medusa's death. A lot of, very Disney, a lot of these myths. Anyway, what you have here, now these are these two constellations we're going to talk about briefly. They're stuck together. We're just doing this. This would seem to be the shape that people would say a horse suggests. Actually, in the sky, it's upside down. See, this would be what is sticking out of the, we call it the Great Square of Pegasus, because this side is another constellation. So there you have it. And over here is like an elongated V, and it is named after the beautiful maiden Andromeda, who Perseus ends up saving from the wicked sea monster, but more about that next month. Also, by the way, one of our friends, Jim, whose laptop I am using, he was spending time in the dome and thought he would. I think this is during the COVID, when hardly anybody was allowed in. You couldn't have crowds. But anyway, he took a picture of M15, Messier 15, which is a beautiful globular cluster. These things look like, a pin, a brooch of diamonds. And this is actually where it is at the bottom, the Pegasus Cluster. There you go. I try to show our own people's work whenever I can when I'm talking about those constellations. Now here, Andromeda, and you can see that I have actually put in little planets here. I've also put in a very tiny version of a picture of the Andromeda galaxy, and this is amazing. This is something you can see in binoculars, okay? I'll try to tell you how you can do it. Okay. Andromeda, here is beautiful Andromeda, and sometimes she's shown with chains. There's actually a beautiful statue of her in the Met. And she is sitting on rocks, and there is a sea monster who is threatening her. And I usually show it. I think I'll probably show it next month. But as you can see, I like photos. I mean, I like, graphics and everything. But when you can show photos, it's closer to what it looks like when you look at the sky. And when you look with binoculars at a very busy part of the sky, this is kind of close to what you're going to be seeing. What I do is take this part of Andromeda where the V fans out from the star that they have in common with the Pegasus constellation. You go 1 star, 2 star, because they're brighter. And then you go up 1, oops. And then you see 2 little stars kind of around a middle. And then you go up a little higher and you see a smudge. And that's all you see. And really, that's all you can see in most telescopes. We get great pictures because we take about 100 exposures, stack them, and then you fine tune the coloring. But you can actually, the fact that you know that that fuzzball is a galaxy really makes such a difference. And it's one of the more thrilling things we can do. Oh, and then this is Rosamunda Pike. She played Andromeda in, Clash of the Titans, War of the Titans, whatever. And I will show Sam Worthington next month when we talk about Perseus. So something for the women. All right. This is a picture, an actual photo taken by one of our members, Donna Harris. And this is the Andromeda Galaxy. And the first time one of our members took these, and everybody was getting more and more sophisticated, we said, no, you just kind of copy and pasted that, astronomy picture today. You really get this. With the exposures, each lets more and more light in, and then you're able to actually get that. And you can see the 2 little baby galaxies that are nearby it. But the extraordinary thing about the Andromeda Galaxy is not only that we can see it, and it's about 2.5 million light years away. And as many of you know, 1 light year is 6 trillion miles, because the distances are so, literally astronomical. We're trying to think of short ways to express them. And that's the distance light can travel in a year. And the speed of light is exceptionally fast, which is 186 miles per second. So we're talking, this is the farthest object we can see with the naked eye. If you really have a dark sky, you would be able to see it. I have never, I don't think I've been traveling around the time when you can really see Andromeda. So I can't attest to that, but a lot of people have. The cool thing is, that it takes a lot of time for the light to reach us. And that's that mind-blowing idea that you're really looking in the past. So when we look at that fuzzball, we're seeing it as it looked 2.5 million years ago. Officially, technically, some things we're looking at might not be there anymore. I mean, a lot of people like to say that, but that is kind of true. It's amazing. And at that point, we were really, this was some early pre-humanoid people. That's when they were starting the human race on the fields of Africa. So that is really very mind-blowing. The other thing about it is that, everything is moving. We're moving around the sun, and that's moving in the Milky Way galaxy, and the Milky Way galaxy is moving through space. This galaxy is hurtling towards us at 250,000 miles per hour. And it's going to take 6 billion years or so to meet us. So this is what, well, 4 to 6. That is what is so cool about it. But there will be a collision, and there's a few really interesting points about the collision. There's so much space. It's not that anything, probably nothing, is actually going to crash into anything else. There's just so much space. There's stars and then planets around there. And I love when they have GIFs showing actually how it's going to happen. This would be a view if we were around. Our sun's going to get old too. That would be kind of cool to look up in the sky and see that thing coming at you. But anyway, this is just sort of a short view of how this would actually happen. And we're starting to move. And here comes Andromeda and the two little baby galaxies. We're not too worried about that. We just will have to move down. And it's also going to take billions of years to finish colliding. And we will become one galaxy at some point. It takes us up to, I think, a billion years. You know, and who knows how many galaxies went into the Milky Way galaxy? You know, we could have kind of crashed into other people, and so too could Andromeda have. Okay, this is the only thing I want to totally mention is that when you go out and you can see Andromeda, I think I already mentioned it, but don't forget, you've got these two stars that are the bottom of the V, they're very bright. This one's very bright. Pegasus, you can see the 4 stars pretty well. And you know, when you go out, you get your eyes used to the dark, but then you're set. This is really a fairly easy constellation to see. You won't make out any of these. You won't make out anything from Andromeda except these 3 guys down here. So go to the first, the second, move up a little bit with your binoculars. You will see one not so bright star, but then you'll go up and there'll be 2 semi-bright stars like here. And then just a tad up, you will see your beautiful Andromeda galaxy. And like I said, even if it's just a smudge, it's a wonderful smudge. I leave you with something my mother said to me when she realized I was really into this hobby. And it's a wonderful wish. And that's how the way we all feel. And obviously you're feeling some of it or you wouldn't be here. It's a happy hobby. We have a lot of people here, some of whom are in here in my acknowledgments. You can learn how to use the telescopes when you join. You can come to our 75th birthday party next month, next year, and get all dressed up. And people will show you, the research committee will show you how to take astrophotographs. So anyway, let me set you free, and I thank you for your time. Enjoy.
How long's the exposure on that drawn about when you add them together? Like hours? Oh,